Good morning children. Today we are going to start a new chapter in chemistry, that is Redox Reactions. It is a very important concept coming in class 11 which we need this year and in class 12 also. A very important concept, that is Redox Reactions. Before we start redox reactions, how we can represent a chemical reaction generally as, yes, it is reactants react to give products, isn't it? Where capital R is representing reactants and capital P is representing products. So this is the general way of representing a chemical reaction. Reactants reacting to give products. And in a chemical reaction, there can be one or more than one reactants reacting to give one or more than one products. So whatever is the number of reactants or the number of products participating in a chemical reaction, all these transformation means the transformation of reactants to product. This transformation takes place through a number of different types of chemical reactions, isn't it? There are different types of chemical reactions happening, and in every chemical reaction there will be reactants participating and there will be formation of products also. So once again, this transformation takes place through a number of different types of chemical reactions, isn't it? So among the different types of chemical reactions, one of the very important type of such chemical reaction is oxidation reduction reactions. Oxidation reduction reactions. Oxidation reduction reactions means wherever there is oxidation, there will be reduction also. And this oxidation reduction reactions, we can simply call it as, together, simply we can call it as redox reactions. Redox, in the word redox, this red is representing reduction and this ox is representing oxidation. So it is a combination of reduction and oxidation taking place simultaneously. So this is the simplest way of representing an oxidation reduction reaction, that is redox reaction. So during other chemical reactions, redox reactions are also taking place with the changes in energy. Energy means like heat energy, light energy, electrical energy, etc. So there will be changes in the energy content also. So like other chemical reactions, redox reactions also takes place with the change in energy. Now there are so many concepts to explain this oxidation and reduction process or redox reaction, and one of the method is classical concept to explain a redox reaction. According to classical concept, how we can define oxidation is, oxidation can be defined as, it is a process in which there is addition of oxygen, or in every reaction we cannot say that there is addition of oxygen, or it is not necessary that in every chemical reaction there must be oxygen, isn't it? So one of the definition for oxidation is, it is the process in which where there is addition of oxygen, we can call it as oxidation. Or we can say that addition of any electronegative element can also be considered as oxidation. Any electronegative element means like oxygen, if there is addition of halogens, addition of fluorine, chlorine, bromine, iodine, etc. or any electronegative element. Electronegative element means the elements which are coming at the extreme right of the periodic table. So if there is addition of oxygen or addition of any electronegative element can be considered as oxidation according to classical concept. Or in terms of hydrogen, how we can define oxidation? If there is removal of hydrogen, the process which involves removal of hydrogen, that can also be considered as oxidation. Now, like as we said earlier, it is not necessary that in all the chemical reactions there must be hydrogen. So, what is another definition for oxidation? If there is removal of any electropositive element, that can also be considered as oxidation. So, these are the two definitions of oxidation according to classical concept. So, addition of oxygen or addition of any electronegative element can be considered as oxidation, or removal of hydrogen or removal of any electropositive metal or electropositive element. What do you mean by electropositive element? Electropositive element means the elements which are ready to lose electron. And we know that when an atom or when an element loses electron, it becomes positively charged. So, electropositive element means which are ready to lose electrons and form positive ions. And we know that metals are always electropositive, isn't it? So, if there is removal of any electropositive element or if there is removal of any metal, that can be considered as oxidation. Highly electropositive metals are actually the metals or the elements that is coming at the extreme left of the periodic table, that means group 1 and group 2 metals. Okay. Now, there is one more term coming connected with oxidation, that is oxidizing agent, or we can call it as oxidant. Oxidizing agent or oxidant. What is the definition for an oxidizing agent or oxidant? Yes, the one which is supplying oxygen. We know that addition of oxygen is oxidation. So, the element or the species which is supplying oxygen will be acting as the oxidizing agent, or the species or the element or the compound which can supply any electronegative element can also be considered as an oxidizing agent or oxidant. Or how we can define an oxidizing agent? From the name itself it is clear, oxidizing agent. Oxidizing agent means it is actually oxidizing other substances. Oxidizing agents means they are oxidizing other substances by supplying oxygen or by supplying a highly electronegative element. Now we know that there is one more definition for oxidation, isn't it? Removal of hydrogen or removal of any electropositive element like metals. So, how we can define oxidizing agent in another way? Yes, the substance which removes hydrogen or which can remove any electropositive element will be acting as the oxidizing agent. Means it will be oxidizing other substances by removing hydrogen or by removing any electropositive element like metals. So, how we can define an oxidizing agent? The short form of oxidizing agent, now from here onwards we will be writing only as OA. So, oxidizing agent, how we can simply define it as oxidizing agents means these are the substances which oxidizes other substances and itself will be undergoing reduction. So, undergoing reduction means, or we can call it as they will be getting reduced. Okay, all these are the new terms you are studying. So, how we can define an oxidizing agent? An oxidizing agent means it will be oxidizing other substances and itself will be undergoing. Undergoing reduction means they are getting reduced. Okay. So, this is about oxidation and oxidizing agents. Okay. And now we will see few examples of oxidation and oxidizing agents. Examples of oxidation and oxidizing agents. 2 mg solid. It's not like 10th standard. When you write the equations in class 11 and class 12, you must write the physical state plus O2 gas giving 2 MgO solid. How we can explain oxidation based on this equation? Here, look at this equation. From this equation, it is very clear that magnesium is combining with oxygen to form magnesium oxide. That means there is addition of oxygen to magnesium. When there is addition of oxygen, we can call it as oxidation. So here, magnesium is actually undergoing oxidation. So here who is undergoing oxidation? Magnesium is undergoing oxidation, or what we can call it as magnesium is oxidized. So who is oxidizing magnesium here? O2. So we can call this O2 as the oxidizing agent. We can call O2 as the oxidizing agent because O2 is oxidizing magnesium to magnesium oxide. So this is one example for oxidation. Another example is Mg solid plus Cl2 gas giving MgCl2 solid. So in the first definition, in the first equation, we explained oxidation in terms of addition of oxygen. But now see the second equation. Can you see any oxygen in the second equation? No. So how we can check whether there is oxidation or not? See, in the second equation, magnesium is combining with chlorine. We know that chlorine is a highly electronegative element because it is group 17 halogen. So here magnesium is combining with chlorine to form magnesium chloride. So how we can define here? Magnesium is combining with a highly electronegative element. So we can say that magnesium here Mg is undergoing oxidation, or we can say that magnesium is getting oxidized. So who is getting oxidized here? Magnesium. Or who is undergoing oxidation here? Magnesium. Now who oxidizes magnesium here? Chlorine. So what we can call Cl2 as? It is acting as the oxidizing agent because it oxidizes magnesium to magnesium chloride. So in the second equation we have explained it is the oxidation we are explaining in terms of addition of an electronegative element. Now another example. H2S gas plus O2 gas giving MgCl2 solid plus 2H2O. See the next equation, the third equation, H2S plus O2 giving sulfur and H2O. How we can explain oxidation here? See here H2S is converting to sulfur. H2S is converting to sulfur means actually what? In H2S there is removal of hydrogen. Removal of hydrogen, we can call it as removal of hydrogen, or any electropositive element can be considered as oxidation, isn't it? So here in H2S there is removal of hydrogen to form sulfur. So what we can say about H2S? It is undergoing oxidation. How? By removing hydrogen, or we can say it is getting oxidized. So who is actually oxidizing? Who is taking that hydrogen from H2S? Yes, see this equation, H2 plus O2, H2 and O2 is combining to form water. So who is taking hydrogen from H2S? It is oxygen. So here oxygen, O2, we can call it as the oxidizing agent or oxidant. Oxidizing agent, another term is oxidant. Okay, so here in the third example, we are explaining oxidation as removal of hydrogen. Okay. The fourth example, 2K4FeCN6 times aqueous plus H2O2 aqueous giving 2K3FeCN6 times plus aqueous. See the last example. Here how we can define oxidation. See the equation properly. On the reactant side we have K4FeCN6 times aqueous plus H2O2 giving K3FeCN6 times and KOH. See what happens to K4FeCN6 times, which is on the reactant side. Yes, it becomes K3FeCN6 times. That means there is decrease in 1 potassium. K4 becomes K3. That means there is decrease in 1, or there is removal of potassium. Removal of potassium means potassium is a highly electropositive metal, which is coming in group 1 in the periodic table, isn't it? So here K4FeCN6 becomes K3FeCN6 times, means there is removal of an electropositive element or electropositive metal, that can also be considered as oxidation. So here who is undergoing oxidation? K4FeCN6 times by removing an electropositive metal. So this is undergoing oxidation, or we can say that it is getting oxidized. And who is oxidizing this K4FeCN6 times? Yes, H2O2. How it oxidizes K4FeCN6 times? In order to understand this equation, H2O2, can we write it as OH, OH? Yes, OH, OH means 2 hydrogen, 2 oxygen, so H2O2. We can simply write it as OH, OH, isn't it? So it is combining with potassium here. So this hydrogen peroxide will be taking potassium from here and becomes KOH. So hydrogen peroxide is actually removing potassium, or it oxidizes K4FeCN6 times by taking potassium from that. So this hydrogen peroxide is acting as the oxidizing agent or oxidant. So this is about the 3 different types of definitions and 3 different types of examples for oxidation and oxidizing agents. Hope it is clear to you. Now, like oxidation, we know that wherever there is oxidation, there will be reduction also, isn't it? So how, according to classical concept, how we can define reduction? Yes, it is just opposite to oxidation. So how we can define addition of hydrogen, or addition of an electropositive element, or addition of any metal can be considered as reduction. or removal of oxygen or removal of any electronegative element can also be considered as reduction. So in connection with reduction, we have another term, that is reducing agent. If a species is undergoing reduction, there must be another species to reduce it, isn't it? So reducing agent, short form is RA. How we can define reducing agent? Reducing agent means it will be reducing another substance and itself will be undergoing oxidation. Reduces other substances and itself will be undergoing oxidation. So remember, reducing agent will be undergoing oxidation. Okay, so how we can define a reducing agent? Yes, which supplies hydrogen, because addition of hydrogen is reduction. So which supplies hydrogen for reduction can be called it as reducing agent. Now addition of electropositive element or any metal can be considered as reduction. So which supplies this electropositive metal or element will be acting as reducing agent. Now we know that removal of oxygen is reduction. So which removes oxygen we can call it as reducing agent, and which removes an electronegative element can also be called as reducing agent. So how we can define a reducing agent? Simply as a reducing agent always reduces other substances and itself will be undergoing oxidation, or we can say that they are getting oxidized. Okay, so they reduces other substances and itself will be undergoing oxidation or getting oxidized. Now we will see few examples of reduction also. The first example we have bromine gas plus H2S gas giving 2HBr gas plus sulfur solid. Look at this equation, the left hand side and right hand side. How we can explain this reduction equation as, on the reactant side we have bromine is reacting with H2S giving HBr and sulfur solid. What happens to bromine here? See the change happening. Bromine changes to HBr. So bromine is combining with hydrogen, or there is addition of hydrogen to bromine. So what we can say as bromine is undergoing reduction, or bromine is getting reduced. Now who is reducing this bromine here? Who is supplying hydrogen to this bromine here? Yes, it is H2S. Who is supplying hydrogen to bromine here? H2S, because H2S becomes sulfur. So H2S is supplying hydrogen to bromine, so it is acting as the reducing agent, or we can say that it is reductant. Reducing agent, another word is reductant. Oxidizing agent, another word is oxidant. Okay, so here H2S is actually acting as the reducing agent or reductant by supplying hydrogen to bromine, so that bromine can undergo reduction. And see what is happening to H2S here. H2S becomes sulfur. H2S become how? H2S becomes sulfur by removing hydrogen. That means it is undergoing what? Oxidation. See, a reducing agent will be always undergoing oxidation. Second example, 2HgCl2 aqueous plus SnCl2 aqueous giving Hg2Cl2 solid plus SnCl4 aqueous. Now see the next equation. How we can define or how we can explain reduction based on the second equation. See the reactant side and product side. HgCl2 on reaction with SnCl2, that is stannous chloride, becomes Hg2Cl2 and SnCl4. Look at each and every species. What happens to HgCl2 here? HgCl2 became Hg2Cl2. How HgCl2 can become Hg2Cl2? Yes, by the addition of mercury. One more mercury is adding to HgCl2. Then only it can become Hg2Cl2, isn't it? So mercury, we know that it is an electropositive metal. So where there is addition of electropositive metal, that can be considered as reduction. So here HgCl2 is undergoing reduction. How it is undergoing reduction? By the addition of an electropositive element, that is mercury. Okay, or we can say that it is getting reduced. So who is undergoing reduction here? HgCl2. Now see what is happening to SnCl2 here. SnCl2 becomes SnCl4. So if HgCl2 is acting as, or if it is undergoing reduction, definitely SnCl2 will be acting as the reducing agent or reductant. And see what is happening to SnCl2 here. SnCl2 became SnCl4. How SnCl2 becomes SnCl4? By the addition of chlorine, which is a highly electronegative element. An addition of an electronegative element like chlorine can be considered as oxidation. So here SnCl2 is acting as a reducing agent or reductant. So that will be undergoing oxidation. How it is undergoing oxidation? By combining with a highly electronegative element, that is chlorine. Okay. Now one more example. CuO solid plus H2 gas giving Cu solid plus H2O liquid. In the next equation, look at the equation at the left hand side and the right hand side, that means reactant side and product side, and observe what is happening to each reactant in this equation. See what happens to CuO here. CuO changes to C. How CuO changes to Cu? By the removal of oxygen. Addition of oxygen is oxidation and removal of oxygen is actually what? Reduction. So CuO is undergoing reduction, or we can say that it is getting reduced. Now, so H2, who's taking this oxygen from CuO? Yes, it is hydrogen. So H2 is acting as the reducing agent, or we can call it as reductant. And see what happens to H2 here. H2 is getting converting to H2O. How H2 becomes H2O? By the addition of oxygen, and addition of oxygen we can call it as oxidation. So H2 is acting as reducing agent, or we can call it as it is the reductant undergoing oxidation. So remember, a reducing agent will be always undergoing oxidation, and an oxidizing agent will be always undergoing reduction. So this is about the oxidation and reduction with examples. Now there is one question to identify the species undergoing oxidation and reduction. See the first equation. In the first example, look at the left hand side and right hand side. That means look at each reactant and each product. On the left hand side we have H2S reacting with Cl2 to give HCl and sulfur. So first we will see what happens to H2S here. H2S changes to sulfur. How H2S becomes sulfur? By removing hydrogen. Removal of hydrogen is what actually it is oxidation, isn't it? So who is undergoing oxidation here? H2S is undergoing oxidation, or we can call it as H2S is getting oxidized. The question is to identify which species is undergoing oxidation and which is undergoing reduction. So here which is undergoing oxidation? H2S. By removing hydrogen it becomes sulfur. Now see what happens to Cl2 here. Cl2 becomes HCl. How it becomes HCl? When chlorine combines with hydrogen only it becomes HCl. So addition of hydrogen is what? It is reduction. So Cl2 is actually undergoing reduction, or Cl2 is getting reduced. Now here who is acting as the oxidizing agent and who is acting as the reducing agent? See, H2S is undergoing oxidation means H2S undergoing oxidation means it will be acting as the reducing agent or reductant. Similarly, Cl2 is undergoing reduction, so it will be acting as the oxidizing agent or oxidant. Okay. Now, in the second equation, this is the second equation, Fe3O4 is reacting with aluminium to give iron and Al2O3. So, look at each reactant which is present on the left hand side and see what happens to each species here. We have to identify which is undergoing oxidation and which is undergoing reduction. So, see what happens to Fe3O4 here. Fe3O4 becomes Fe. How Fe3O4 becomes Fe? By the removal of oxygen. We know that removal of oxygen is called as reduction. So, Fe3O4 is undergoing reduction, or we can call it as it is getting reduced. Fe3O4 is getting reduced. And see what happens to aluminium here. Aluminium becomes Al2O3 by combining with oxygen. So, addition of oxygen or combining with oxygen, we can call it as oxidation. So, who is undergoing oxidation here? Aluminium. So, it is undergoing oxidation, or we can call it as it is getting oxidized. Now, once again, Fe3O4 is undergoing reduction means it is acting as the oxidizing agent, or we can call it as oxidant. Similarly, aluminium is undergoing oxidation means itself will be acting as reducing agent, or we can call it as reductant. Okay, now in the last example, to identify the species undergoing oxidation and reduction, equation is Na plus H2 giving NaH. So here we can explain which is undergoing oxidation and which is undergoing reduction only in terms of electropositive metal or electronegative metal. We cannot explain based on hydrogen. Sodium is combining with hydrogen, so can we say that sodium is undergoing reduction here? No. So here the explanation is sodium is combining with hydrogen means hydrogen is a less electronegative element. It is not electropositive element, it is electronegative, but electronegativity is less. So, how we can say the explanation for sodium here? Sodium is combining with hydrogen, that means which is a less electronegative element. So combination with a less electronegative element or an electronegative element can be considered as oxidation. So here sodium is undergoing oxidation. How it is undergoing oxidation? The explanation is by combining with a less electronegative element, that is hydrogen. So undergoing oxidation or getting oxidized. Okay. Now how we can explain for hydrogen here? Hydrogen becomes NaH, isn't it? So hydrogen is combining with sodium. We know that sodium is an electropositive metal. So combining or addition of electropositive metal can be considered as reduction. So here H2 is undergoing reduction or getting reduced. So sodium undergoing oxidation means it will be acting as reducing agent or reductant. H2 undergoing reduction means itself will be acting as oxidizing agent or oxidant. So this is about the classical concept of oxidation and reduction.